Today's lesson is on section 5.6, which is finding rational zeros. Now, in the past, you've been given a huge hint where they have told you what one of the solutions is, or they have told you what one of the factors is, and then you're using that particular solution to go ahead and try to find the rest of them. Well, from here on out, they're not going to give you solutions. You're going to have to find them yourself. Well, we have a process to do that, and this process is called finding P over Q. So we can find all possible rational zeros by doing P over Q, where P is all the factors of A sub 0. A sub 0 is going to be our number in the back, so this is going to be our P term. And then we're going to look for Q, which will be all the factors of A sub n. A sub n is going to be the term in the front. And what we're going to do is list those possible factors. We'll list all of the P numbers, we'll list all of the Q numbers, and then we have to do this fraction right here, P over Q. So in this particular sample, f of x equals x to the third plus x squared minus 3x minus 6. We're going to start with our number in the back. This is going to be our P value. P is 6, so we have to list any numbers that multiply together to give us 6. Plus and minus 1, 2, 3, and 6. Now you need to show plus and minus because you could be doing positive 1 times positive 6, you could do negative 1 times negative 6. So you need to show that by listing both plus and minus with all of them. Then we move to our number in the front. We don't have a number, so we assume it's going to be 1. This is really easy because the only factors that work would obviously be just plus and minus 1. Well, then we put the whole thing together. We've got P over Q. Your P value will be all of your numbers 1, 2, 3, and 6. Your Q value will be just plus and minus 1. And then you need to put it together, every single thing on the top over every single thing on the bottom. 1 over 1, 2 over 1, 3 over 1, 6 over 1. And these right here would be your list of possible rational zeros. Now that doesn't mean you're going to use all of them. There are actually 8 numbers listed here. This is a third degree equation, which means you're going to be looking for 3 possible solutions. Those solutions could come out of this list. All right, let's do this first equation where we're going to list all the possible rational zeros. Again, we're looking at the number in the front and the number in the back. The number in the back is 8. That's A sub 0. And we need to list all the possible numbers that could work to give us 8. And again, we need to put plus and 1 down. And I'm just going to put this once, knowing that we would use it over and over and over again. 1 times 8, 2 times 4. A sub n will be our term in the front. That number is 2. And the only numbers that multiply together to give me 2 are 1 and 2. My possible zeros will be P over Q plus and minus 1, 2, 4, and 8 over 1 and 2. And when I put all of them together as all the possibilities, I get plus and minus 1, 1 half, 2, 2 over 1, or excuse me, 2 over 2 is 1, and I already have that. 4 over 1, 4 over 2, which is 2, I already have. 8 over 1, and then 8 over 2 is 4, which I already have. So this list right here would be all of the possible zeros that could work in this particular question. Now we're going to try to find the possible zeros and then actually look for the solutions that we could get for that. Now, the way we do this is list all of our choices, just like we finished doing on the last slide, but then we have to take this one step farther. We're going to actually have to do synthetic division to see which one of these possible values actually works. Now, the bad thing about doing synthetic division is that we may have to do this over and over and over again until we finally get the one that works. How do we know which one works? We have to get 0 as a remainder when we do our synthetic division. This example we're going to work through is f of x equals 2x to the third plus x squared plus 10x plus 5. My number in the back, P value, is 5. So the only things that work will be 1 and 5. My number in the front is 2. That represents my Q value. And the only thing that works to give me 2 is plus and minus 1 and 2. When I put all of this together as my P over Q values, we get plus and minus 1 and 5 over 1 and 2. And when I list all of them, I get 1, 1/2, 5, and 5/2, plus and minus for all of these as my possible choices. Now, if you notice, we've got 2, 4, 6, 8. We've got 8 possible rational solutions here. This is a third-degree equation. I'm looking for 3 answers. These 3 answers may come out of here. Well, how do I know which ones could be right? Here's where the synthetic division is going to come in. What we need to do is practice synthetic divide until we get 0 as our remainder. So what you want to do is try to pick one of these numbers off of your list. You've got 8 to pick from, and I always like to start with the easiest one that I could find, which for me would be trying +1 and -1. So let's put in -1 first. And remember, when we look at these as the factor, x minus 1 gives me x equals 1 as a solution, and x plus 1 gives me x equals -1 as a solution. So just remember the difference between what the solution is and what the factor is that it comes from. So if I try x equals 1 first, that means I'm actually using it as the factor of x minus 1. Hopefully you remember your process on synthetic division. Drop the 2, and then it's multiply, add, back and forth. Multiplying gives me 2, add is 3, multiply is 3, add is 13, multiply and add. I get 18. 18 gives me a remainder. That remainder is supposed to be 0. So this number of 1 is not a solution. So now let's try another number. Let's try -1. Drop the 2, -2, add, we get -1. 1 is 11. -11 gives me -6. Also not 0 as a remainder. But now I want you to notice that we had a sign change in our remainder numbers. This number was a +18. This number was a -6. Positive number versus a negative number means that in between 1 and -1, someplace it had to cross the graph. If you think about what this equation is doing, this is a third-degree equation. It's looking like this on a graph. So I'm trying to figure out where my solutions could be 0. If I let x equal 1 or x equal -1 and look at these ordered pairs, 1, 18, if I could graph that, versus -1, -6, these two ordered pairs are on opposite sides of the axis. This one is way up high, this one is way down low. So someplace in there my curve actually has to cross. That crossing point will be my solution. So if I want to try to pick a number between 1 and -1, we're going to key on these numbers next, 1/2 versus -1/2. Well, let's try the +1/2. Drop your 2. Half of 2 is 1. Add is 2. Half of 2 is 1. Add 11. Half of 11. 11/2 or 5.5. And when I add, I get 10.5. Well, that's not 0 yet either, which means it could be this one right here. So we'll try this one more time. Multiply, we get -1. Add is 0. Multiply is 0. 10, and -1/2 times 10, -5. And I finally got 0 as a solution. So, what does that mean? That means this, x equals -1/2, is one of my solutions. I want to try to find the other 2 solutions. To find the other 2 solutions, I'm going to use the numbers that are on the bottom and write the equation. This is now 2x squared plus 10. I need to factor that. I could take out a 2, x squared plus 5, and then I'd have to factor x squared plus 5. Well, x squared plus 5 doesn't factor. So can I try to solve this as an equation setting it equal to 0? X squared plus 5 equals 0. X squared equals -5. X equals plus and minus the square root of -5. X equals plus and minus I root 5. Those will be my other two solutions. Now you notice these two solutions are I terms. That means they're not rational. That means negative 1/2 is the only rational root for this. I get two other solutions. They just happen to be complex values. Now, we don't want to have to do synthetic division all the time. That's going to take way too long. You don't want to have to keep trying every single rational number until you finally get something that works. So there's got to be a way that we can use our calculators to help us narrow down the choices. I'm going to show you how you can go to your calculator, graph this, and then look to see where your curve actually crosses. The process that we'll go through is to go to your y equals screen first. Then you're going to type the equation of whatever it is you're going to graph. Usually we set a window every single time, but for us now we're going to do a real shortcut graphing window, which is at zoom 6 for buttons. And I'll show you where to find all these in just a second. What you're going to look for then is where does it look like your curve is crossing the axis? You want to use one of those numbers as your possible synthetic division. Once you do your synthetic division, then we can factor the other pieces to the equation and come up with our solutions. All right, so let's look at the same equation that we just did, 2x to the third plus x squared plus 10x plus 5. But we want to use our graphing calculator to help us. Okay, so grab your calculator, turn it on. I'm going to bring my calculator up here too so you can see it. The first thing you need to do is hit your y equals button. Y equals button is on the top row, far left. So hit your y equals button, and you're going to have this screen show up. Now if you have anything left over typed right here, we need to get rid of that. So we're going to hit our clear button, and it just erases it. The other thing I want you to look for is, do you have a dark box that's around one of these words, plot 1, plot 2, plot 3? If you do, we don't want that there. So we have to turn our plots off. Use your up arrow, so your plot 1 should be blinking. Hit the enter button, and then arrow back down again. So when you go hit the up arrow, and then hit enter and arrow back down again, it should turn that plot off. That way it's not going to be plotting any scatter plots that you might have someplace in your calculator. So you should have a clear screen right now. Now you're going to be able to type your equation that we were just looking at. So check your notes if you have it. The equation was 2x to the third. 2, your x button is right here next to the green alpha. So if you type 2 and then that x, now we're going to use our hat key, which is on the far right hand side. That's raised to the, and we're going to be raised to the third power. Now if you have a really new calculator, you notice that you've got a little arrow blinking right here. We need to get out of being in that power position. So if you use your right hand arrow, it tabs over, and then you're back in line with the rest of the equation. So we can keep adding plus x squared. You've got a squared button, which is on the far left side halfway down, right here, 2x, or x squared, and then plus 10x and plus 5. 2x to the third plus x squared plus 10x plus 5. Now I want to graph that. So here's where we can use a shortcut method for graphing. If you look on the top row in the middle, you've got a word that says zoom. And then if you go to choice number 6, that's the standard window, which plots everything between negative 10 to 10 on the y-axis and negative 10 to 10 on the x-axis. So here's the picture of that particular screen. What we are interested in is this position right here, where your curve is crossing the axis. That's the spot that we think is a solution. Well, that spot looks like it could be negative 1/2, which is one of the possible rational roots that we had. Okay, so negative 1/2 is the possible spot that we used as our synthetic divide. So now if I bring my slide back up again and go backwards here, do you notice that this number, negative 1/2, this is the number that we actually found after trying synthetic divide 4 times, we finally got one that actually worked, negative 1/2. Well, if we can bypass doing all of these divisions and just jump to the one that we think is actually crossing the axis, that takes some of the work away from us. So we're still able to do one synthetic division and then be left with the numbers that we're going to use as the rest of our factoring. Okay, so let's use our calculators and let's try this next example. F of x equals 3x to the third plus 12x squared plus 3x minus 18. First thing we want to do is list the possible roots. P-values, plus and minus 1, 2, 3, 6, 9, 18. Q-values, plus and minus 1 and 3. So our list of possible roots would be 1, 1/3, 2, 2/3, 3, 3/3, which is 1, 6, 6/3, which is 2, 9, 9/3, which is 3, and 18. Plus and minus, those are all of the possible roots. Well, I do not want to do synthetic divide with all of those. So now we're going to use our calculator to see if we can narrow down that whole list of choices and find something right on that we can divide with. So let's go back to our calculator. We're going to go into our y equals again, and we're going to clear out the equation we just had. Hit your clear button. We're going to type in the new equation that we were just looking at. 3x to the third. Use your hat key, raised to the third. Remember to tab over if you need to. 3x to the third plus 12x squared plus 3x minus 18. Double check that you typed in the correct numbers on your calculator, because if you do type something incorrectly here, you're obviously not going to get the correct picture that you're looking for. Go to Zoom, 6, and here's what your graph is going to look like. We're interested in where we think it's crossing the axis. Well, this one looks really nice because it crosses 3 times and it crosses right on every time. There's negative 3. This one is negative 2. This one is positive 1. So I actually have 3 choices that I could use as my synthetic division. Negative 3, negative 2, or 1. And if it were me, I'd go with the positive number. Okay, so let's go back to our work. Here's our synthetic division lined up, and I want to try positive 1 because it looked like it crossed at positive 1. Drop the 3, multiply and add, multiply and add, multiply and add. I got my 0 as my remainder that I was supposed to get. So now I've got my solution. I need to write that as an equation, 3x squared plus 15x plus 18, and I need to be able to factor that to come up with my other solutions. Do you notice a 3 is in common all the way across? Take that 3 out, x squared plus 5x plus 6. This is now factorable. 2 numbers that multiply to give me 6 that add to give me 5, x plus 3, x plus 2, and now I can use my zero product property to verify that x equals negative 3 is indeed a solution and x equals negative 2 is indeed the other solution. Those are the other 2 spots on the graph that I could have used as my synthetic division. So, depending on what the question is asking you, it may say, what are the factors in which case we will write x plus 3, x plus 2, and then this one, if x equals 1 is the solution, that means it came from x minus 1. So if it asks me for the factors, it'll be x plus 3, x plus 2, x minus 1. And remember, we actually took a 3 out from that whole thing. If it asks me for the zeros, then I have to actually write down those solutions. Negative 3, negative 2, and 1. Now, you do have to show me at least one synthetic division. And based on this one synthetic division, you need to show me by hand the work necessary to get the other solutions. You can't just go to the picture on your calculator and say, oh, my answers are negative 3, negative 2, and negative 1, with no work to justify that. I do need to see other steps along the way, so make sure I see information that's like this. Okay, we're going to do one more example. 9x to the fourth plus 3x cubed minus 30x squared plus 6x plus 12. Possible solutions. Plus and minus from 12 would be 1, 2, 3, 4, 6, 12. And on the bottom, plus and minus 1, 3, and 9. Okay, so we've got a big list again. Now we're going to go to our calculator, clear out what was in the original y equals screen. We're going to retype our new equation, 9x raised to the fourth, tab over to get out of there, plus 3x to the third, tab over there, minus 30x squared, plus 6x, plus 12. Zoom, 6. And I get a couple spots that might work. Now, this one is in between. This one looks right on -2, so I want to try that one for sure. Looks like +1 might be a choice, so I might be able to do that one as well. This is actually a 4th degree equation, so I'm going to have to do synthetic divide a couple times. This one is a little iffy, could maybe be -1/2, but I'm not sure. And then there's another one that crosses right here that's a little bit above 1. So let's keep in mind the numbers -2 and +1. All right, synthetic division. 9, 3, -30, 6, 12. We're choosing -2. Drop the 9, -18, -15, 30, 0, 0, 6, -12, 0. So yes, -2 is a solution. It came from the factor x plus 2. Now I want to try 1, 9, -15, 0, 6, and we're trying the number 1. Drop your 9, 9, -6, -6, -6, -6, 0. So yes, that one works. X equals 1 is the solution. It came from x minus 1. And now I've got this stuff on the bottom. 9x to the second minus 6x minus 6. And we have to try to factor that. I could take out a 3. I'm left with 3x squared minus 2x minus 2. And then I need to try to factor. Okay, well I will tell you that this doesn't factor, so the only thing you can do to solve to get your actual solutions is your quadratic formula. So if they're going to ask me for the complete factorization, it would be 3x squared minus 2x minus 2 times x plus 2 times x minus 1. The solutions, the rational solutions, are -2 and 1, and then I'm going to get some other solutions out of this guy. And that's where I'm going to have to use my quadratic formula. X equals -b, plus and minus the square root. B squared minus 4 times a times c, all over 2a, which is 6. 2 plus and minus the square root of 4 plus 4 times 3, 12 times 2, 24, all over 6. 2 plus and minus the square root of 28 over 6. Square root of 28 has a 4 in it as a perfect square. That's going to come out as a 2. 2 plus and minus 2 root 7 over 6. And I can divide each one of these three terms by 2. 1 plus and minus root 7 over 3. Those would be my other two solutions. So my solutions, 4 solutions to this equation, are x equals -2, x equals 1, and x equals 1 plus or minus the square root of 7 over 3. 4 solutions, only 2 of them were rational, and the complete factorization, if they asked for it, would be right here. Okay, tomorrow in class we're going to do together homework number 31, which will be very similar to this ugly one that we just did right here. Okay, so tomorrow in class, question number 31 together.